Guess who's back? Back again. The Voron Trident build is back. And I'd first like to start this video by apologizing to you guys for taking so long to get part 3 of this video series back up and running. And I'm sure you guys can relate. Sometimes you got a lot of different projects and things going on, and you put something down for what you think is only gonna be a week or two, it turns into a month or two, or more. And this is kind of what happened with this project here. I got sidetracked with a bunch of other things, and so I'm sorry that it took so long to get to this point in this build, but I think I owe an even bigger apology to Dyze Design. These guys donated their Extruder Pro and HotEnd Pro kit for me to put and install on the Voron Trident. And it's a very exceptional piece of equipment, and I've had it sitting here for so long, and I feel so bad to those guys for making them wait to get this video out there and tell you guys about their product and how I'm gonna use it in this project. That being said, their patience with me has been absolutely legendary. They haven't even reached out once to try and pressure me to hurry up and release this video. So a huge thank you goes out to Dyze Design. I can't wait to show you guys how I'm using their Extruder Pro and HotEnd Pro kit on the Voron Trident build. And before we get started, I just want to remind you guys, as with all of my other videos, always check the video description down below if you're looking for things like design resources or links to products or items that appear in my videos. You'll find a lot of extra information down there. So let's get started. As with most of my projects, I start with the 3D model, and this one is no different. And so what you're looking at here is the 3D model of the printhead using the Dyze Extruder Pro. I've completely redesigned all of the Voron parts to fit the Dyze Extruder Pro and to be printed in the HP MultiJet Fusion process. At the back of the printhead, you'll see my own custom PCB, and we'll get to that later. Right now, we're gonna take a look at the printed parts. So I have all of them sitting out here, and the first is the fan grill. Next up is the mount for the part cooling fan. Then we have the hot end mount. After that, we have the wire cover. Then we're gonna get into these parts that are gonna receive these brass M3 threaded inserts. The first is the extruder mount. There's actually gonna be 6. I have only 4 inserts sitting in front of that part, but you'll see later there will be 6. The next is the part cooling fan ducts, and this will have 4 of the threaded inserts. And then finally, the part cooling fan cover, and that's just gonna get 2. In a previous video, I designed a press to heat up these threaded inserts and press them into plastic parts. You can find a link to that video in the top right-hand corner of the screen. It works just as well with MultiJet parts as it would with regular FDM printed parts. Sometimes you do get a little bit of plastic that overflows around the insert, and you should clean that up with a hobby knife like I'm showing you here. The end result is having all 3 of these parts with the threaded inserts very securely in place. And if you pay close attention, the extruder mount gets 6 of those inserts in total. And then moving on to the part cooling fan duct, it'll have 4, so there'll be 2 in the back, and then you have 2 in the front, and it's those bottom 2 holes that get those inserts. And lastly, the part cooling fan cover just gets 2 in the top at the back of the part. Now we can focus on the front and back part cooling fan covers, and we're starting off with this back cover here. You'll see there's an opening where the 4020 radial fan will sit. Now if you look at the fan itself, there's clips all around the body of the fan, and we're going to use a razor blade to unclip the front cover, and we're not going to be reusing that front cover. We're going to completely remove it. Once you get the front cover removed, you're going to take the wires, bend them back a little bit in preparation for inserting the fan into the new back cover. Make sure the wires didn't get snagged at the back, and once it's in place, it should sit flat. Then we can take our front cover and simply put it right on top. If everything fits correctly, you'll notice that there's no gap in the seam between the 2 halves of these parts, and the fan on the inside should not rattle around at all. Now we're going to take 2 M3x16 socket head cap screws, and we're going to thread those in through the back of these 2 parts. And if you remember, we put heat set inserts into the back of the front cover, and so that's what these are getting threaded into. Remember that you're clamping down on plastic parts, so do not over tighten the screws. Now we can take a look at the crown jewel of this entire build, and that's the Dyze Design Extruder Pro kit. And so the kit comes with both the Extruder Pro and the HotEnd Pro, and again, this was very generously contributed by Dyze, so huge thank you to you guys. When you open the box, one of the first things that might catch your eye is this graph here, and that's an extrusion force graph. as part of the quality control test that each of the hot ends and extruders goes through. Now we can take a moment to geek out for a second and look at some of the technical specs of the Extruder Pro. So it's extremely strong with 22 pounds of force. It's also got this really slick toolless hot end removal with a latch type mechanism to hold onto the hot end. There are these really interesting looking cooling fins that get sandwiched between the body and the stepper motor. They also claim that the dual pinch drive system with those completely redesigned teeth allows for a higher pushing force, but with less of a chance of flattening your filament, even with a higher tension. Considering its all metal construction, it's reasonably lightweight and has a fairly small form factor. And speaking of all metal, the reduction gears are all metal. You'll find no plastic gears in this entire thing. And they claim that their spring mechanism within their gear drive system applies a nice constant pressure on the filament. And depending on what you're building, it doesn't have to be used in the direct drive configuration. It's also Bowden tube ready. And again, if you're planning on building something else, on their page you can download the 3D CAD model to design whatever bracket you need for whatever machine you're building. We can look at the spec sheet all day, but when I hold it in my hands, I do get that feeling or sense that I'm holding something of high quality and craftsmanship. In the box, I've also got the HotEnd Pro, which is similarly packed with high-end features. Let's have a quick look at those features, and the first thing they have listed is the tungsten carbide nozzle. Now, tungsten carbide is one of, if not the hardest nozzle materials on the market. That means it's going to work great with all of the abrasive filaments that you can throw at it, and you'll likely never have to replace it. You've also got a ceramic coated transition tube, so that's the heat break, and that's going to eliminate heat creep up through the heat break, which will prevent hot end jams. It even has an in-canal sealing washer, which I have not seen on any other hot end on the market, and that's likely because you can get these hot ends up to 500 degrees Celsius, so they have temperature sensors to support those temperatures for very exotic materials. If you want to go the liquid cooling route, you can. In my case, I'm just using the regular air cooling, and that liquid cooling adapter is not included in the kit, but you can fit it on the regular Pro hot end. They also list the nozzles as cold swappable, which is great so you don't burn your hands, and the nozzle thread size is a very stout M10, which is much larger than the standard M6 that you'll find on most other hot ends on the market. Of course, you can use the hot end with a Bowden tube setup if that's the direction you want to go, and it's got the groove mount, which I had mentioned fits into that latching type mechanism on the extruder when you want to use it in the direct drive configuration. And as with the extruder, if you want to use this thing for a different application, you can download the 3D CAD information to design your own mounting solution. They also have a suggested list of plastics that you can use with the hot end, and of course, if you configure your hot end to reach temperatures of 500 degrees Celsius, the sky is really the limit on what you're able to process. And so on paper, this thing is one of the top of the line hot ends that you can buy right now. And later on, when we finish the build and we go to test it, we will of course find out if it is the best in practice. In my kit, I also have the 500 degree thermistor as well as a 24 volt heater cartridge. Additionally, all of the connectors and wiring harness bits and pieces are included that you'll need to interface with all of the connectors coming off of the hot end and the extruder, so they've got you covered in that department as well. Now we can start mounting this beautiful hot end to the hot end bracket, and you'll see there is a receptacle in the top of the bracket that corresponds with the top throat of the hot end. At the bottom of the bracket there are some tabs or fingers, not entirely sure how to describe those, but those will slot into the heatsink fins and hold everything securely in place while we get the rest of the bolts tightened down. I'm also going to firmly push this hot end into place, and I'm going to make sure that the hole in the top of the hot end is concentric to the semicircular hole in the top of the bracket. Next, I'm going to remove the 4 screws holding the hot end fan in place, and that's because I'm going to just be rotating that fan 180 degrees so the connector comes out the other side. Then when I go to put the screws back in place, I'm only going to put the top 2 screws back for now, and we'll deal with the bottom 2 screws after. Right now we're going to be focusing on the heater cartridge and thermistor, and so the heater cartridge gets clamped into place using this screw at the side, and we're going to have to do this step now because later on that screw is probably going to be inaccessible because of the part cooling fan duct. Now before inserting the heater cartridge into that bore, I like to prepare it with this copper-based anti-seize compound. I use this stuff in the same manner that I would use a thermal paste, and it's non-flammable and rated up to 2200 degrees Fahrenheit, and that's about 1200 degrees Celsius. My intuition tells me that since it's copper-based, it should be a very good conductor of heat, and I've had this can for a really long time. As you can see, it does look pretty old, and it's never dried out. So let me know what you guys think down in the comments section if this is a good stand-in for a very high temperature thermal paste, or maybe you guys think I'm crazy. Let me know. Either way, I'm using it on this project, and I've actually already used this on plenty of other 3D printing hot ends, and I've never had an issue. It always has worked out great. I'm going to make sure it's evenly distributed around the heater cartridge and inside of the bore, and then I'll be able to tighten down the screw that clamps it in place. Next, the thread on the thermistor is going to get the same treatment with the copper-based anti-seize compound, and then I'm going to tighten that thing down with a 7mm wrench. Keep in mind that tighter is not always better, and when you are working with smaller components, especially in materials like brass and aluminum, you do not want to over tighten these components as you could strip threads. Looking at the hot end from the front, you can see that I'm going to take all of the wires and bundle them up and towards the right side of the hot end. Now I can slip the part cooling fan duct on top of this entire assembly, and I'm just going to wiggle all of the wires and cables aside, make sure nothing gets snagged in there or pulled on, and then I can press the part cooling fan duct in with the hot end mount and make sure that there is no gap between those two parts. Once I'm satisfied with the fit, I'm going to grab the two original screws from the hot end fan, those bottom two ones that we had left out, and now they are going to help assist with holding the part cooling fan duct in place, as well as the bottom of the fan. These coarse threaded screws grip into the fins of the hot end heatsink, so do not over tighten these either. Now we can look at the back of the assembly, and we're going to be using some M3x16 socket head cap screws, and those are going to get inserted in the top of the hot end bracket. I'm going to be putting some blue Loctite on those so that they never come loose, because later on in the assembly they're going to be very inaccessible if we ever have to retighten them. It would take a lot of work to get these back out and be able to access them. After that, I'm going to grab a 17.5mm long piece of Capricorn PTFE tubing, and I'm going to force it down into the top of the hot end, and that's eventually going to interface with the bottom of the extruder, and so it should stick out a certain amount. Just make sure it's fully seated. Now I'm going to take all of the wires coming off the hot end, and I'm going to put them in the strain relief channel on the right hand side of the part cooling fan duct. I'm going to try to get them to sit as flat as possible without obstructing any of the other mounting holes on this piece here. And once I'm satisfied with their position, I'm going to take a small zip tie, and you'll see there is a very small channel that passes through this part and allows you to wrap the zip tie completely around those cables. Then I can test fit the fan grill and make sure the wires aren't sticking up high enough to interfere with the relief in the side of that grill. Now we need to prep the extruder before we can attach it to its mounting bracket. And if you'll notice, at the top of the extruder there is this black thumb screw, and we're going to completely remove this. Then we can take a look at the bottom, and you'll find an M3 socket head cap screw attached to the latching mechanism. We're also going to remove this. With the latch removed, we can turn the extruder around, and we're going to be focusing now on the screws at the back of the stepper motor. The two screws on the right hand side of the stepper motor, when looking at it from the back, those are also going to get completely removed. Now we can grab our extruder mount, and we're going to need two M3x25 socket head cap screws as well as two M3x10 socket head cap screws. The extruder will sit flush at the front of the mount, and the two holes at the side will line up with the two holes in the side of the Dyze Extruder Pro. I would recommend using some thread locker on these screws, and then you're going to insert the two M3x10s into the side and fasten those down. The two M3x25 socket head cap screws will get inserted through the back. Again, I recommend using some thread locker here, and this is originally why we removed the two screws on the back of the stepper motor. And if you have everything lined up and mounted properly, you should see light passing through the bottom of the bracket right through the extruder and out the other side. Before we start mounting our assemblies, if you were going with a limit switch attached to the X carriage, I would recommend installing that now, and you'd be fishing the wires through this hole back here. In my case, I'm going to be using one of these combination XY homing limit switch PCBs, and that gets attached to the back of the frame, and so you're not going to see me attach a limit switch to the back of the X carriage. In addition to the mounting provision for an X limit switch directly on the X carriage, I also left these holes in the design where you could epoxy in a magnet for a Hall effect sensor limit switch. Again, this is not something that I'm doing, but it is there if you decide to go that route. Before attaching the hot end, just make sure your Omron switch is in a good position. Now the Voron manual recommends about 6 millimeters from the bottom of this bracket, but I found with the Dyze Design kit, you're going to want to extend that Omron sensor down about 7 to 7.5 millimeters, measured from the bottom of the sensor to the bottom of the X carriage bracket. Then we're going to grab some M3x8 socket head cap screws, and we're going to use these to attach the HotEnd assembly to the X carriage bracket. As always, do not over tighten these screws, and then you can grab your two M3x40 socket head cap screws, and those are going to get inserted through the bottom two holes in the part cooling fan duct. And again, I would recommend using thread locker on all of these screws because this printhead is going to see a lot of vibration. Before installing the extruder assembly, make sure that your auto bed leveling cable is sitting nice and flat inside of the channel at the top of the X carriage assembly. Otherwise, it might prevent the extruder from seating properly. Line up the hole at the bottom of the assembly with the PTFE tube, and then just sit it on top and press it down firmly. Grab two M3x20 socket head cap screws, apply a little bit of thread locker, and then insert those through the back of the X carriage, and those will grab onto those brass threaded inserts that we had installed in the extruder bracket earlier. If everything is done correctly, the extruder assembly should be seated flat against the X carriage. At the front, we can install the part cooling fan, and it's just going to sit on top like this, but the wire for the radial fan is a bit too long, and that's because I'm going to have a Toolhead PCB installed at the back of the printhead that this thing is going to connect to. Rather than cutting the old connector off and having to re-crimp new terminals, it's easier just to desolder those wires, cut them, and then resolder them on shorter. And with that done, I can grab some M3x30 socket head cap screws, and those are going to go in through the two holes at the bottom of the part cooling fan assembly, and that's going to fasten the part cooling fan in place. Next, the front fan grill can go on, and the top of the fan grill hinges about a piece of filament. So I'm just going to take a piece of standard 1.75 millimeter diameter filament, fish it through a hole in the side of the part cooling fan piece. Then I can place the fan grill in place, and that piece of filament should just be able to push on right through the two parts and create that hinge. Then I can secure the bottom of the fan grill in place with two M3x12 socket head cap screws. Finally, the piece of filament can be cut on both ends, and friction should be sufficient enough to hold it in place. The assembly is starting to take shape, and I did mention that I have a Toolhead PCB that I designed specifically for this application, and you're looking at it right now. The first connector here is a Microfit 3.0 for the heater cartridge, and then on the side there's another 14-pin Microfit 3.0 connector, and that's for all of the wires coming in off the main board. There's also a JST connector on the back for the 80XL accelerometer, which we can use later for input shaping with clipper. And up at the top, you'll find a female header pin, and that's where we'll actually just plug the accelerometer directly into the board. On the front side, there's a bunch more JST XH connectors. The first one at the bottom is for the ABL sensor. Then we got one for the extruder motor, and we got another for the hot end fan, part cooling fan, the thermistor, and then the unpopulated one would be for the X end stop, which I'd mentioned earlier we're not using on the toolhead. The incoming connector into the PCB is a 14-pin Microfit 3.0 connector. And so I found a 14 conductor cable, and this is from IGUS and it's part of their Chain Flex series, so it does work really well inside of an energy chain. I've created a GitHub page to document this entire PCB. You'll find a link to that down in the video description, and you can see I've printed off the schematic for this PCB. As I push the terminals into the connector, I'm going to record all of the colors of the wires and their positions in the connector so that I have this documentation later on when I go to wire my main board. And it doesn't matter if you're crimping terminals for a microfit connector or JST connector, you do not need an expensive specialty tool. You can make these connections and crimp them with a simple crimper like this, and I'll put a link to one of these down in the video description down below. I also did a video specifically about these tools, and I'll put a link to that in the top right hand corner of the screen. In addition to the IGUS 14 conductor cable, I also took each of the cables that were included in the Dyze kit, and I cut the ends off of them, and I terminated them with connectors compatible with the connectors on my PCB. The first one is for the heater cartridge, the next one is for the thermistor, there's another for the hot end fan, and finally one for the extruder motor. With all of the wiring prepared, now we can get the wire cover on the side, which is going to hold the PCB in place. And to do that, we need to remove the other two screws in the back of the stepper motor on the left hand side. Push the wiring and cables that are already on the printhead through the back of the wire cover so that they're not getting in the way, and you'll see that the two holes in the back of the cover line up with the two empty holes now in the back of the stepper motor. You can use M3x25 socket head cap screws or M3x25 flat head cap screws, and earlier on the right hand side with the extruder mount, I originally suggested using the socket head cap screws, but I did switch over to the flat head cap screws for a cleaner look. At the side of the wire cover, there's a single M3x8 socket head cap screw holding the front of the wire cover down in place to the side of the extruder. I've taken the wires coming from the hot end and I've pushed them through the opening of the wire cover at the front, and you may also notice here that I've changed the connector on the heater cartridge. So the one that comes with the Dyze hot end is extremely large, and the connector just looked a bit clunky and it wouldn't really fit through that opening. So I went ahead and replaced it with a Molex Microfit 3.0 connector, and those are rated up to 5 amps, so it should be no problem for our application. At the back, you can see all of the connectors now sticking out, and we're going to be plugging those all into our Toolhead PCB, and then we can fasten the PCB in place, and I'll show you guys how that works. So back in the 3D model, you can see the PCB in green, and you'll see it held in place at the back with these pan head screws. They are thread forming screws, so M2.5 by 6 millimeter long, and it's the same screw up at the top holding the ADXL accelerometer in place. Those two pan heads are now in place, and as I said, they're thread forming screws, so they will thread directly into the plastic wire cover where there's two holes in there to mount this PCB. You'll also notice all of the excess wire is gone, and I've plugged in the extruder motor, so all of that excess wire is bundled up inside of the wire cover. Now I can plug the ADXL 345 into the header at the top of the PCB, and keep in mind here that this is a genuine Adafruit ADXL accelerometer. I noticed that some of the knockoff sensors out there do have a different pinout, so just be aware of that and reference the schematic that I provided in the GitHub link in the video description to see if yours will be compatible. The accelerometer gets fastened down and held into place with another M2.5 by 6 millimeter long thread forming pan head screw. As you can see, this build is a lot of work, but when things come together like this, it does make it all worthwhile. All of the custom MultiJet parts that I designed for the Dyze Extruder Pro and their Pro hot end are at this point one of a kind, but I do hope some of you guys decide to use them on some of your Voron builds. If you guys are interested in one of these PCBs for your build, whether it's a Voron or another custom machine, be sure to check that video description down below for the GitHub link or my website where I might be selling these as well. So that's it for part 3 of this video series, where I finally unveiled my design for all of the parts to support the installation of the Dyze Design Extruder Pro and HotEnd Pro kit on the Voron Trident. I hope you guys are finding this video series interesting and informative, and I can assure you that part 4 will not take nearly as long as it took me to get part 3 uploaded. So again, I'm sorry it took so long, and another big thank you goes out to Dyze Design for your patience and your contribution to this project. And another friendly reminder to you guys, check out my website, embracemaking.com, where you can support me and all of the work that I do on these projects. And don't forget to check the video description down below for all of the related resources that go into the Voron Trident that I've been building. Thanks for watching.